This is application number 3 in my series of desktop applications. This is a medical application. It models patient data and it uses the models to predict the conscious state of a patient in an operating theatre scenario. It was developed for a company that makes products used to train anesthesiologists or makes products that are used in the real scenario where a patient is administered to a hospital, receives an anesthetic drug in preparation for an operation, and this application can be used to model the patient's conscious state before, during and after the procedure. The application consists of 3 independent parts. Firstly, the Enterprise Java Beans client you see here. The client connects via WebSockets to a Spring Boot server, which then connects again via WebSockets to an Android client. I will now outline in a little more depth the components that make up this application. A central display that a nurse would monitor at a nurse station. A client that would be used by a medical professional or the patient themselves as they're being prepped for an operation. And a server, Spring Boot server, that ties everything together. The parts, the display and the client communicate over TLS either by HTTPS or WebSocket secure. We'll just demonstrate the parts now. So here we have the display. This models the patient in response to a drug. Select a patient that's available. We get the basic stats of the patient. And now we will start the modelling that will model the patient's response to the administration of a drug. And for that assessment process, we assess is the patient responsive or not. We have the option to record a voice assessment, but we'll bypass that now for simplicity. So now we're in the modelling stage. There's no drugs being administered to the patient, so the patient should be fully conscious. This is where the client comes in. So we log into the particular patient and we send an assessment. So now if we look in the model, we should see the patient response turn up, and that turned up over WebSockets. So now the patient is going to be administered a drug. The nurse is aware of this, so she can model the drug response. So we enter a dose of a drug, an anesthetic drug, so we will give them 100 milligrams of propofol. So administer that drug. So this is the actual modelling for that drug. If you've had a procedure, or you've been anaesthetised, you understand you go under very quickly, within about 10 seconds. So at the moment, the probability that you will be under is low, but it's rapidly increasing. So now it's up to 60-70%. Up here, this is around the 90 to 95% range, so the patient is already most likely unconscious and ready for the operation. So we could check that, because we don't want to be operating on people that aren't unconscious, no matter what our scientific modelling tells us. So we perform another assessment. So this happens at the patient, and there's the response. So the patient is not really unconscious. So we have the option to add a second drug. This patient has some ability to resist anesthetic drugs, so we can say, okay, we really need to knock them out. So in this we can add another drug and model the effect of another drug. So now we have another dose of fentanyl to increase the probability that they will be unconscious. So now it's recorded that second drug. So we could perform another assessment, and this process can continue. So it's meant to be used in a medical setting where a patient is administered to a ward, visited by an anesthesiologist, administered a pharmacokinetic drug. Then the responsiveness of the patient as a result of those drugs is modelled theoretically by the display, physically via this client. And this client program can be an Android tablet or a native program on a tablet. By that I mean JavaFX. So you could have a Mac tablet running a JavaFX program, or you could have an Android tablet running Android. So what I'll do now is just stop this part of the demonstration and talk about the code. This is the source code for the application. A display which models the patient, a client, a tablet or an Android where we can perform the responsive assessment, and a Spring Boot server that ties the whole thing together. because it's in a medical setting, patient information security is really serious. So we've got our own self-signed certificate set up. So this code just sets up the certificates that are used for the WebSockets, secure WebSockets and secure HTTP. So it's just basic code for setting up self-signed certificates. Now the Spring Boot server is just using the standard Spring Boot technology. This was put together over late 2016, 2017, extending a little bit into 2018 as the company asked for more features. So it started just with the basic display, then we moved on to the client and the distributed application with the server. Then they introduced more sophisticated models. So the models are in this module here. This is the scientific module, if you like. So all the modeling code that models the response to the drugs, so it simulates the response to the patient with particular statistics to various doses of various drugs. So that evolved over time, quite a bit of code in there. The application evolved over about 18 months. So Spring Boot, setting up Spring Boot with TLS, nothing could be easier. You just set it up in the application properties. Very easy to configure Spring Boot for HTTPS, and just the typical JPA that you find in Spring Data JPA. So it's just typical Spring Boot. You've got beans, configuration beans. The WebSocket was a little bit difficult. WebSocket support in Spring Boot is not fantastic, so it relies on Stomp. Here I'm not using Stomp, which was a bit of a battle. Getting Spring Boot to talk to Android and not use Stomp was difficult. It's very easy if you take the JavaScript approach and use Socket.js or whatever it is. There's a JavaScript client that's pretty universal for WebSockets and Stomp. So we weren't using that, so it's a bit of a challenge. Then the client module is very interesting. It's set up so you have one source code that works on Android and the tablet. So the desktop here is the tablet. So we demonstrated the client. You saw it was a very simple thing, but it's a JavaFX desktop that can run on Android. To achieve that, it uses this plugin called JavaFX Ports. So here's the plugin there, JavaFX Ports. JavaFX Ports has morphed into this company called Gluon, and I've done some work with Gluon. License is fairly expensive, so it's worth it to learn how to use the open source plugin. So that's a client. Then the display, which we saw, is just a JavaFX desktop set up with a plugin for the modeling. You saw we had that canvas where we were painting the models. Look in the chart, this is where we have our canvas. So we have our canvas where we plot all our models. I used to sort of produce a pattern. So we have a canvas where we can scroll. It's a scrolling canvas. And we have these lists of data that's set up in a producer pattern. One thing I forgot to mention is that this application is using Enterprise Java. As in the last application, where I had Enterprise Java, we have a ubiquitous Beans XML. So we're injecting using Enterprise patterns. So we can have qualifiers, we can have producers, we can have this thing we're calling a model result. So this is a qualifier, if you like. So when we're producing something, here we're producing data. So we can qualify on the type of data that we're producing. So here it's drug info. So here it's an effects keys and effects values. So we can produce and qualify on the production to the type of data that we want to end up in these lists. So that Enterprise Java pattern sort of made the amount of code much less. So nicer code, cleaner code. It's easier to see what's going on, and you can sort of organize things, and in the process of organizing, you're sort of broadcasting what is the type of data in this list fairly clearly. So you could have that in the actual name, but it's nice in the annotation. So that's the actual display. So it's using Enterprise Java Beans, and it's modeling the patient's response. So it's displaying the model. We're generating the model in this module. We have the client, we have the transport layer, security, and we have the Spring Boot server. I developed this application from scratch. Just to quickly summarize, a distributed application where we have an independent display application, an independent tablet application, and a remote server. The display uses Enterprise Java, but the server was Spring Boot. The client is a cross-platform application which runs on Android, a desktop-type tablet like a Win8 type tablet, or an iPhone or iOS type tablet. The display runs scientific models. The client interacts with the patient to assess responses, and the server allows secure bidirectional transport via WebSockets.